Hey everyone, in today's video I'll introduce a new topic, that is fundamental laws of absorption. So we have discussed two main processes in spectroscopy, absorption and emission. Mainly absorption takes place basing on two main laws. One is Lambert's law and another one is Beer's law. So let us see Lambert's law today. Okay, so when a beam of monochromatic radiations, for example, I'm taking a monochromatic light which is having a single beam. That means what? Mono means single and chroma means color. Single color light, we are passing through a pure homogeneous medium. Homogeneous medium, whenever you are passing, the intensity of light, beginning there will be some intensity that is called intensity of incident light. So after some time the intensity decreases along with the thickness of medium. Okay, this rate of intensity, the rate of decrease of intensity of radiation with thickness of medium is directly proportional to the I naught value, that is intensity of incident light. So beginning there is some intensity for the monochromatic light, that is I naught, intensity of incident light. So after some time there is a decrease in both intensity and thickness. So that is indicated with the di by dx. Okay, di means d indicates a small change. So decrease in the intensity, small decrease in the intensity of light along with thickness of medium is directly proportional to the I naught value. Okay, so here after some time, next step what I'm doing, I'm removing this proportionality symbol and I'm keeping the absorption coefficient, that is K, constant value, proportionality constant. So I got the equation 1. After next step what I will do, I bring this I naught to this side and x to this side. So minus di by I naught is equals to k dx. This is the second equation. Now we got equation 2, that is minus di by I naught is equals to k dx. Okay, so on rearranging, this equation becomes di by I naught is equals to minus k dx. So this equation 3, I am doing integration from the limits I naught to I, 0 to x. So upon integration I naught to I, integration of I naught to I di by I naught is equals to 0 to x integration k dx. Okay, so this you can see, this can be written as log I naught to I. That means what? You can see integration of dx by x is equals to log x. Same way integration of di by I naught is equals to log I. So in place of this I wrote log I. Log I naught to I is equals to minus k, 0 to x dx. Okay, so next this can be written as log I minus I naught is equals to minus k x 0 to x limits. Same way this can be written as log m minus n is nothing but log m by n. Same way log I by I naught. And next this will become log I by I naught is equals to this, limits will become x, because 0 to x limits is nothing but for x, so minus kx. So I got equation 4. So for this equation, if I take anti-logs, I by I naught is equals to e power minus kx. So this I naught, if I bring to this side, I is equals to I naught into e power minus kx. So now we got equation 5. We got an equation I is equals to I naught into e power minus kx. So this is equation 5. So in order to get I absorbed radiations, I am doing I naught minus I. That means I absorbed radiations means intensity of radiations absorbed in the medium. So when you are passing radiations, there will be some incident radiations I naught, and there will be radiations which are passing through the medium, transmitted radiation. So intensity of radiations after passing through the medium is I. So in order to get, if you subtract both, I will get the I absorbed, that means intensity of absorbed radiations. So I absorbed is equal to I naught minus I. So I value already we know, I'm substituting this value here. I naught minus I into e power minus kx. So we got equation 6. So now I'm taking equation 4 again. Log I by I naught is equals to minus kx. So to this equation I'm changing the natural log to base 10. So 2.303 log 10 I by I naught is equals to minus kx. So if this 2.303 come this side, then the equation becomes log 10 I by I naught is equals to minus k by 2.303 into x. So now what I will do, this k by 2.303 is considered as k dash. So log 10 is equal to I by I naught is equals to minus k dash x. Okay, so now this log 10 comes this side. Okay, so then I by I naught equal to 10 power minus k dash x. So if I bring this I naught to this side again, I is equals to I naught into 10 to the power of minus k dash x. So here k dash is called as extension coefficient. So relation between k dash and k is nothing but k dash is equals to minus k by 2.303. So now let us see the physical significance of k dash. So from equation 7, we know equation 7, log 10 I by I naught is equal to minus k dash x. If I rearrange this equation in order to get k dash is equal to minus 1 by x log I by I naught. Okay, so this can be on further rearrangement 1 by x log 10 I by I naught power minus 1. Okay, this becomes reciprocal in the next step, 1 by x log I naught by I. So if I substitute 1 in this place, log I naught by I is equals to 1, then the equation becomes k dash is equals to 1 by x. Okay, so when this I by I naught is equals to 10, then only this value becomes 1. So for example, I by I naught, if I take 10, log 10 base 10 is nothing but 1. Then only there is a possibility for 1 by x. So if I take I by I naught is equals to 10, then if I can get I value. I is equals to 1 by 10th of I naught. So k dash, I got I value now. So k dash can be defined as thickness of reciprocal of thickness of absorbing medium. So k dash is nothing but 1 by x, reciprocal of thickness. X is nothing but thickness of the medium, at which the intensity of light is reduced to 1 by 10th of its original value. Whenever we are reducing the intensity of light to 1 by 10th, then only the equation becoming 1 by x. Yes, so k dash is nothing but reciprocal of thickness of absorbing medium, at which the intensity of light is reduced to 1 by 10th of its original value. Okay, so this is completely about Lambert's law and physical significance of extension coefficient. Thank you so much for watching.